Now let's do this. Now we got the 3, 2, 1, go countdown. All right, so if I got a circle and then I got a line, okay, those two different things can interact in one of 3 ways. Okay? Either the line, and I'm actually going to work right to left here on this one, either the line doesn't touch the circle at all. That's a possibility, where the line doesn't touch the circle at all. There's an example of it. Or it intersects at one point. We call that a tangent. A gentleman that spent too much time on the beach. A tangent. Oh, come on. Come on, man.
I give it a 4 out of 10.
No one cares about your opinion. Exactly.
What? Are you on your period this week or something?
No, you are. Remember, you told me. Okay.
That was harsh. That was harsh. That was rude.
Rude. Yes. Okay. Or it can intersect at 2 points, and that one I got no joke to go with this one. Secant. I don't even have one for that one.
I'm not talking to you.
Good. Okay. So we got those 3 scenarios. We're only going to focus in on one of them today. We're going to focus in on another one in 2 weeks. Okay. So we don't really care about this no intersection one. Okay. Because that doesn't do us any, mathematically doesn't do anything for us. Okay. So that's the one we're not going to care about. Today we're going to focus on tangent lines. Okay? And in 2 weeks, we're going to focus in on secant lines. Okay? So I lied. 3 weeks. It's the last topic we do. Okay? All right? So we got that. Now, I have to remind you that, from geometry, that the radius, okay, so I'm going to look up here on the tangency one, okay, so the radius, we'll call that R, okay, so the green line segment is perpendicular to that tangent line right here at what's called the point of tangency. I think I spelled it right. So it's perpendicular at that point. Now, you may be saying to yourself, self, why do we need to know that fact? Well, today's lesson is going to be finding not the equation of the circle, but the equation of the tangent line. Okay? So remember, we'll also have to get a pre-member here going on with the point slope form of a line is y minus y sub 1 equals m times the quantity x minus x sub 1. That's what if we have a point and we have a slope, that's what we use to find the equation of a line. Yeah? And then we also have the slope intercept form of a line as y equals mx plus b. So we're going to have those two come into play. Yeah? Let's do it. Let's dive right into one. Shabam. Here we go. Write the equation of the line tangent to the circle at the given point of tangency. So this first part here, this is my circle. This part here is my pot. That point of tangent. So, based off of what you know about the circle, where is the center of that circle? At the origin. Yep, the center of that circle is at the point 0, 0. Correct? We know that this is the point of tangency. It's at 6, 1. Does anybody know why those 2 points are important to us? Yeah. We already know the radius, though, right? Okay. We already know the radius is the square root of 37. Okay. But we could have found the radius by finding the distance between them. Yes. The slope of what?
I don't know. So,
Slope
the
of
circle.
the point.
Slope of the.
Is it the point slope?
No. That's the next step. Okay. The slope of
The line?
which line?
No.
The tangent line?
No, the radius.
The radius. That's what I'm looking for. We can find the slope of the radius now. Okay? Alright? So here's why we're going to do that. Yes, ma'am?
So, are you going to make us like draw the circles on like tests and stuff? Cause like, are we going to have to
Like on these particular scenarios?
Yeah.
No.
Okay, so then we won't have to worry about like the line. Like, would you ever mark us off of the line not being like
No,
in the right
no.
spot?
No. Okay? So the first thing that we're going to do is we are going to find the slope of the radius. So, Eo, back to what you had first said. What is slope?
Rise over run.
Rise over run, or subtract the y's over subtract the x's, right? Okay? So the slope here is going to be subtract the y's, 1 minus 0, over subtract the x's, 6 minus 0. Correct? So I get a slope here of the radius as 1/6. Yes? Okay. If we did it the other way, we would have gotten 0 minus 1 over 0 minus 6. We would have had -1 over -6, which still would have reduced to 1/6. Okay? All right, so that's the first thing you're going to do. You're going to find the slope of the radius, and you're going to use center to the point of tangency. Those are the 2 points that you're going to use. Okay? Now, let's go back here to this. The radius is perpendicular to the point of tangency, or to the tangent line at the point of tangency. So now what we have to do is now we're going to find the tangent line's slope. How do I take an existing slope and make it perpendicular slope. Find the what? No, not radical.
Multiply it by its reciprocal.
Multiply it by its reciprocal? Divide it by its reciprocal?
Subtract, add.
Add, subtract, square? None of them work. Because we're looking for, there's two operations that we have to do to make it perpendicular. We got to find its reciprocal. That's one of them. I'm going to take down the second one because that's really the naughty thing. Yeah? Right? Because otherwise I'd be sitting here like this. Okay? Right? So we got to find the reciprocal as one, but then there's one other thing we got to do. That's the reciprocal part.
Oh.
Think about perpendicular lines, right? Okay? So make perpendicular lines with your hands, right? Or your arms or whatever. Are they going in the same direction? No. So one is negative and one is positive, right? So what do we call that when we got one negative and one positive? It's an O word. Opposite. So perpendicular slopes are opposite reciprocals. So what is the opposite reciprocal of 1/6? -6. Gotta do both. We gotta flip it and we gotta negate it. So the opposite reciprocal would be -6. See how this is all like coming back? We got a little bit of algebra, we got a little bit of geometry, a little extra algebra 2. Did I? Yeah. Outside of this class, it was the longest class that I taught.
Wait, when did you start teaching algebra 3?
Long time ago. Like, I want to say 04, 05, somewhere in that range. Yeah. 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 So, what did I do? Mm-hmm. Yeah, I'm on round 2 or generation 2 of students. Yeah.
That's terrifying.
Algebra 2.
Yeah, what did you do? Do you have to teach the same thing every year?
Nope.
So you wouldn't get bored?
I like to mix it up every once in a while, but this is the one that I'm in because I got to have my certification through the NTC. So then lastly, what we're going to do is we're going to use the slope and the point of tangency to find the equation. Okay? So my slope that I'm going to use is -6. We got that from the very last step. My point of tangency is 6, 1 from the original problem. Okay. What we're going to use is y minus y sub 1 equals m times x minus x sub 1. Because we have a point and we have the slope. So we're going to use the point slope form. If we had the y-intercept and the slope, we go right to slope-intercept form. We don't. So we got that. So this is going to be y minus 1 equals negative 6 times the quantity x minus 6. Y minus 1 equals negative 6x plus 36. So I get the slope, or the tangent line y equals negative 6x plus 37. That's the equation of the tangent. Questions, comments, concerns, clarifications, other things? Fantastic. You do that one. Find me, oops, I probably should have wrote down the equation. Find me the equation of the tangent line. Center. 2 comma 5. Point of tangency is at 2 comma negative 3. Okay? So this picture is obviously not an accurate representation, because what is the slope of the radius? Oops, I should do it this way. M of the R, of the radius. So that's going to be rise 5 minus negative 3 over run 2 minus 2. That gives me 8 over 0, which is undefined. Right? No. If it was 1 underneath it, the 8. Yes. Okay? But can I reciprocate that? Can I reciprocate that? I got to do opposite reciprocal, right? So if it's 8 over 0, the opposite reciprocal would be negative 0 over 8. What is negative 0 over 8 reduced to? Just 0. Yep, just 0. So my perpendicular slope is 0. Third step. So that's going to become y minus negative 3 equals 0 times x minus 2. Oops, that was supposed to be a different color. That's 0 times anything. 0. So then this is just so the slope of my tangent line is y equals negative. Had it been the other way around, where the radius was horizontal, then the vertical line would have been the tangent line. They still have to be perpendicular. So then it would have been x equals 2 if we would have switched this scenario. Okay? X equals lines are vertical. Y equals lines are horizontal. That hasn't changed forever. Okay? So, sitting here now, you now, on your green worksheet for this week, you can do all 12, you can do all 12 problems now. Really, you should only have those last 2 to do. Okay? All right, so you got that. Then also, 29 minutes ago, this week's summative quiz opened up. Okay? So you could take that one. This one is a little bit longer than last week's because there are some last week questions on it. Okay? So it's kind of, we're going to kind of do in this, because this unit is really long. Okay? Because it's going to be like a 7-week unit. Okay? So what I'm doing is I'm going to cycle through stuff. So each quiz now on each Friday quiz is going to have some questions from before this week, and then the majority of questions though from this week. Okay, so there's circle questions, yes, but then there's parabola questions too. And next week when we get to ellipses, there will be some parabola and circle questions in there too. Okay. Sounds like a plan. Sounds like you guys have stuff to do. So I'm going to let you get to it.